Okay, this is an RC circuit problem. I put the description of the problem below the video if you want to pause it, write it down, and so that way you can follow it more easier, or maybe solve it and then check later for the solution here. So the first part is asking us to find the time constant. Find the time constant for this circuit. So the time constant is tau equals RC, and this one comes from this formula. This RC is what we're looking for. So we have R and we have C. This part is pretty straightforward. Tau equals RC. R is 5.00 ohms times the C, it's right here, 0.500 farads, and this will give us tau equals 2.50 seconds. There you go, the first part, that's it. Okay, the second part wants us to find the current in R after 10 seconds. So we're gonna use this formula for that, but we're gonna use a different version of it. We're gonna substitute I for E over R, and this way we can substitute stuff in easier. So let's write down IR equals, we're gonna, our EMF is 20 volts, our R is 5.00 ohms. There you go. We have E on the power of 10 seconds on top. There you go. And our RC comes on the bottom. And our RC, we know that is tau, so we can go ahead and just plug this one in. 2.50 seconds. There you go. IR equals, if we solve it, plug in a calculator, we'll get 7.33 times 10 to the negative 2 amps. There you go. That's the second part. Third part is asking us to find the maximum or final charge on the capacitor. So at this point we know that well, we're gonna put T goes to infinite after a long time. We know that the current will be 0 amps after a long time, right? So that means in the voltage in the resistor will be 0 volts. Now, knowing this, we're gonna resort to the loop rule and do a loop like that, and let's write it out. Starting at the EMF plus EMF, go around, minus the voltage on the capacitor, minus the voltage on the resistor, equals 0. This one we know is 0. We have only these two left, and that's actually very good because V on the capacitor equals EMF, which equals 20 volts. Okay, this is just part of it. And now we're gonna use this V to find our Q. So for this one we're gonna use this formula, Q equals CV. So to find our Q, C is given 0.500 farads times our voltage, what we just found, it's 20 times, let's write it here, 20 volts. So our maximum charge that we're gonna have on the capacitor will be 10.0 coulombs. There you go. Okay, the next one. So this one is asking us how many time constants does it take for the charge on the capacitor to reach 1/2 of final charge. So I noted this one in such a way that our time equals how many time constants for the instance when our charge is 1/2 of our final charge. So writing this in such a way will be quite helpful. We're gonna use this formula, and here, as we can see, we can use this equation that we created to plug in here and start solving for our t, and this will be our tau. Alright, let's proceed. So instead of Q, I'm gonna go ahead and straight plug in 1/2 Q final. So 1/2 Q final equals this Q final, and this part stays the same. 1 minus E on the negative T over, I'm gonna replace the RC with just the tau. In this case we are interested in the tau, we're not interested in the pieces of RC and the components, so I'll just use it that way. Okay, now we can see that we can get rid of the QF. It's on both sides, so we can simplify it out. Let's see what we have left. 1/2 on this side, and here we have whatever is left in the parentheses. So 1 minus E on the negative T over tau. There you go. Let's take the 1 on the other side and multiply the whole thing by -1. So we make the negative disappear from front of the E. So 1/2 equals E on the negative T over tau. Alright, now we're gonna take a natural logarithm of both sides, ln. We're gonna have ln 1/2 equals ln of E will cancel each other out, so all we're gonna have left on this side is our exponent. So negative T over tau. There you go. This one is just a number. Plug it in the calculator. We're gonna get 0.693 equals T over tau. The negative disappeared because this will be a negative number. So this negative with this negative all will just cancel out. So we have nice positive values. Let's solve for T. T equals 0.693 tau. And there's our answer. Okay, this question is asking pretty much the same thing as this one, but it's asking the charge at 0.99 QF of final. So 99% of final. So we're gonna follow the same footsteps. We're gonna use this formula, start plugging in, and follow it down all the way till we get here. Exactly the same. So I'm gonna do it faster. Since the logic is already here, you can just follow along with the numbers. Okay, on this side, 0.99 Q final equals Q final. There you go, 1 minus E on the negative T over tau, parenthesis closed. Q final was gone. This one I'm gonna bring out here. It's gonna be 0.01 equals E on the negative T over tau. Take a ln of both sides. ln of 0.01 equals ln E. Cancel each other. We have T over tau. This is a number we calculated. It's gonna be 4.605 equals T over tau, and solve for T. 4.605 tau. There you go. That would be it.